Everybody, it's Tyler here at the Purdue SIGBOT Slam and Jam VEXU event, checking in with Devils coming in from UW Stout. This team has a really cool set of robots and some really cool features as well too. Custom PCB they'll be jumping more into, but I love this belay system that they're using to start the match as well too, to get that goal rush. Really cool and innovative, and surprising more teams are doing it. Maybe they will now, you never know. More stuff on this, a lot of 3D printed chassis actually that we diving more into, and we follow that ring journey, covering some other great aspects as well. So let's learn more about Devils coming up here on Pits and Parts. And let's dive into this robot here. Talking about you're running a 10-motor drivetrain, so I'd love to hear more about that, the chassis you're rocking, and then a little bit more on your Mogo mech too.
Perfect, yeah. So to start off with, this is PJ, our 15-inch robot. So these robots are pretty much identical, but except for some key components used in our goal rush as seen in the 24. But this one features a 10-motor drive with a fully 3D printed chassis. Surprisingly, has worked very well, but the main basis of this robot is modularity. So that's why you can kind of see these segments here. And because of our ability to 3D print, we can definitely optimize our time building and reiterating as fast as we can. We don't have to replace the main components. So that's why you see these seams here, mainly with how the motors are mounted as well. They're flush in the 3D prints, which allows us to utilize more space here, seen with our odometry. These use a custom linear slide to allow us to track our movements on the field a lot better than the motor encoders themselves. I think moving on from there, if we flip her around and look at our Mogo mech. So this is our main way of interfacing with these mobile goals. Now, we wanted a very, very direct way of ensuring that we do not lose control of these goals. So we use a locking linkage system, which is fully 3D printed as well, to make sure we can have that perfect geometry every time. We utilize 2 screws here. We kind of call them vampire teeth because they really bite in. They kind of hang lower than the goal. They allow us to almost get a very, very secure grab into this. We haven't had any issues with losing a goal yet this match. We have had people try and pull us away, but with our 10-motor drive, it proves to be very difficult to at least take it away from the DevilBots.
Something I want to ask you, go back to that custom chassis. What has your experimentation been like in regards to using mostly 3D printed material for a chassis? Like, have you had any big cracks or structure failures or anything like that at all?
Oh yeah, there's definitely been some cracks or structural failures. Let me not tangle this one up here. Moving to the front of it, if I flip it around. The front of the robot, we've seen parts completely explode. If you want to lift up the arm, Austin. Thank you. So these here, we usually use draft PLA because we go through a lot. We went through about 10 kilos so far in the past 4 months. But these ones here are ABS because of how violent we are with this robot against the wall, against other goals, against other robots. And these take a beating, but with ABS, we're able to refine and swap out these components very fast, which is a simple screw set, and it just goes right back on.
It's hard to plan for robots with physical bricks in them too sometimes, right?
Exactly. And we found that out the hard way, especially with our arm here. We can talk more about it later, but it took a beating on this robot. It is still split in half, held in with super glue and bolts the other way. But it works right now, and we're still kicking it.
Well, if you want to donate to the upgraded PLA fund, we'll post that Venmo link in the description of the video as well too with that. Let's pass it over to Eli, talk more about that arm, and then just how this all functions as well. Watching on the field, very effective for that, and I like the claw that you're utilizing as well too.
Yeah, so our arm, it serves 2 purposes. Obviously, we take rings. Can somebody man the controller here? Aiden, where's the... Okay. Yeah, so obviously we can grab rings from the floor, and you notice, can you let go here? We have these screw points to grab the rings instead of something like rubber or a flat, large contact surface area, because we found that when you're going for that high alliance neutral wall stake, it's better if this ring can pivot a little bit, because the geometry of our arm is such that the ring is kind of sitting vertical when we're at that height, and you need it to be like horizontal to get it down on the stake. So we found that this passive pivot that those screws provide allows that to happen naturally. And then you can lower the arm, Austin. Lower it. And then the second thing it does is it allows us to intake these rings without knocking them away. So can you run that? Intake? Yeah. So these 2 plates here, they just keep the ring from flying off and in this direction, contain it in the robot. And
I want to ask you about match strategy a little bit on this. The last match we just saw, you had this clutch play, putting the ring up on the Mogo really last second. Can you just talk to me a little about that experience?
Yes, we did. Yeah, so that's the great thing about having this arm. It's super versatile because you can raise it up to any height you want. So we can do mobile goals, we can do alliance-specific stake, we can do neutral wall stake. And we can also knock goals over with the arm, we can tip them back up. So yeah, it's just proven to be a really versatile mechanism for us.
Very multifunctional. Anything else you wanted to cover on this?
I think that's about it for the arm.
All right, let's pass over to Eva to talk more about how this intake's working as well too, and utilizing the hooks as well. I'd love to just hear a brief overview of what all goes into this.
So these hooks are made out of 3D printed, they're made out of flexible TPU. It's less brittle than PLA would be, so that'll prevent that from breaking. And the curved geometry helps pick the rings up too. We also had issues with the chain itself separating. So if this gets caught on something, it'll pop the chain open. And that usually doesn't happen, but our robot can still function like this. And in a previous match, before we installed the string, we had a chain fall off and get caught in a drivetrain. So this, it's looped around each link and then around the outside of the link and then onto the next link, so that prevents, we had its tails get tangled in the sprocket too. So.
Have you had to redo or reapply the string or anything like that, or has it held up pretty well for you?
We had a couple issues around where the hooks are attached. What we ended up doing is just doing string on the second side for a small segment to reinforce it.
Before we go into the program, I want to pass it back to Aiden real quick and talk about, we mentioned earlier, you guys have this really cool system for starting out the match and then getting that Mogo rush. So walk me through what you guys have for that. This is really neat.
Yeah, so in our match analysis, we determined that the goal rush is one of the most important things, because if you lose that in VEXU, especially with the offset number of goals on that center line, it can definitely swing a match. So we wanted to make sure that we can reach that goal as fast as we can, as soon as we can. So we started here with a string mechanism that uses, it's almost like a badge reel. You can pull it out, it comes back in, but the issue is it needs to lock. So once it does lock, it holds out completely and it doesn't come back in, and it utilizes a mechanism similar to like a climber when they have the belay on the ground. You're releasing tension, you're adding that bite to the rope, and it holds it out. And it all does that passively, which was a main design point that we wanted to integrate with our bot, especially since we're so constricted on space and we want to work on this tier 3. We don't want to limit ourselves by using up all the space for just a string mechanism. So as soon as we lift up our intake, it retracts it with no extra parts, just by utilizing the spring on the inside of this reel here. And so with this in mind, we use this advantage of starting distance with the addition of our mobile goal hook. Now this is about our third iteration. Again, this is 3D printed for weight, and it's this draft PLA, which is very flexible. It's not too rigid. We can move it, we can flex it, and it won't snap, or at least snap yet. It allows us to get an extra reach into those mobile goals and pull them back as soon as we can in auto. And then we chose to do it off the backside because it allows us to very easily integrate our code to just turn to the side and clamp with this locking clamp to ensure that we get this possession of this goal as soon as we can in the match.
Let's wrap on this robot, pass it over to Austin. Talk about, you got a custom PCB. I'd love to hear more about that as well. And then utilizing VEXBridge as well too. Let's talk more about how this all kind of integrates together.
Yeah, sure. So we decided early on that trying to debug programs and software with VEX, it can often be a pain in the butt just because of the limited availability of being able to debug values, being able to get values back from the robot, being able to print values, especially when the robot is running around the field all over the place. So we designed a system called VEXBridge. It's basically a small custom PCB here that adapts into the normal VEX V5 connector, and it allows us to connect into a typical Raspberry Pi like you'd see in other vision applications. And we have software running on it that allows us to debug a variety of other values on it. So for example, we can see the robot movement as it's moving around the field here. This is just showing odometry. We can graph values. It helps a lot for PID. So as the robot moves around, you can see the values pop up and down there. It allows us to view log values, and it allows us to view the hardware statuses, so we can see if values are disconnected with the robot or if things are disconnecting, reconnecting randomly throughout the match, which can happen if you have like bad cables, for example.
Devils, this is a very complete system here, and it's really cool to watch you on the field and everything that goes into it. So congratulations, putting together an awesome set of robots here. And I think a lot of great things, even just past robot, a lot of great individual mechanisms teams can dive into, a lot of great software as well too, and a lot of stuff teams can learn. So thanks a lot. Can't wait to see how you do here. But honestly, keep up the great work and inspiring the community. Really appreciate it and appreciate your time. Thanks a lot.